What's going on, guys? In this video we are going to see how to solve a first order linear differential equation. Now first of all we have to know what is the standard form of a first order linear differential equation. First order linear differential equation means the maximum power has to be 1. Here you can see the y is 1 and we have to have first order derivative, like first derivative. So if you have y square or something like that, it is not a linear differential equation. Okay, now let's go ahead and see a standard pattern. Now this is not in standard form. The standard form should look like this: dy over dx, and we have to have a function of x, p of x, and that one should be multiplied by y, and then after the equal sign we have to have another function of x. So this is the standard form of a first order linear differential equation. Now if you compare this pattern with this one, here we have cos of x dy over dx plus sine of x y is equal to 1. Here you can see for the standard form we don't have to, we shouldn't have anything in front of this dy over dx, but here we have a cos x, right? So to bring this one into standard form, what we have to do is we have to divide everything by cos x. If we do that, we divide this one by cos x, this one by cos x, and this one by cos x. If we do that, this is going to become a standard form. Now if we divide cos x over this one, cos x cancels each other, we will get dy over dx, and here we have sin x over cos x, that's going to be tan x y, and 1 over cos x is sec x, so this is going to be sec of x. Now we have the standard form. Now whenever we have first order linear differential equation, the first thing we do is we find the integrating factor. The reason we do the integration factor is it's going to make everything much easier. Like the equation for the integrating factor is mu is equal to e power integral p of x dx. Okay, now what is p of x? P of x is whatever the value that's multiplying this y, and you can see here like p of x is in standard form. After dy over dx, p of x y comes, and p of x is the function of x that multiplies y after this. Here if you compare this pattern here, you can clearly see this tan x is the p of x for this function. Okay, so from this one we can say this is our p of x. Now after we find out our p of x, we have to find out the integrating factor, because there's a reason behind it. I will show you what it is. Now first of all, let's go ahead and find the integrating factor. This is the equation for the integrating factor, that is mu is equal to e power integral p of x, and we know that p of x for our linear first order differential equation is tan x. So we put that one right here and do the integration. So if you do the integration of tan x dx, that's going to give us sec x tan x. Actually tan x, if you take the integration of tan x, that gives us sec x, ln of sec x. So this is going to be e power ln of sec x, and we will have a constant, but we don't have to put that constant for this. Okay, because here what we are going to do is we are going to multiply this e power ln of sec x both sides of this equation. That's the reason of integrating factor. But before we do that, let's go ahead and simplify this one. Here we can simplify this one furthermore, we will get an absolute value of sec x. Okay, now here the negative value doesn't matter, because after we find out the integrating factor, we have to multiply this integrating factor both sides of this equation. So we have to multiply integrating factor here. Let's go and write this one with a different color. So I have to multiply this one with the integrating factor, this one with the integrating factor, and this one with integrating factor. Okay, let's write it here, multiply by integrating factor. So here if we have a negative value, what will happen? Since we have this one in both sides, we can cancel the negative and it will become positive everywhere, right? So the negative doesn't matter, so we can always take the positive value of this one. Now here, after we multiply this one, what's going to happen is, the reason for integrating factor is it's going to make this one much easier. Like you can write this one as d over dx and sec x y, and we can just write this after you multiply this one, you can just write this term and you can get rid of this one, because if you do the find the derivative of this one, you will get this one back, because this is chain rule. if you do the derivative of this one, you will get this one back. Okay, you can try this one and see, you will get this one back. That's the reason for integrating factor. When we do the integrating factor, we can get rid of this one and make it simple as like this, right? So this is going to be simple, and we just have to equalize this one to this one. So here what we are going to have, sec square x, and now after we multiply everything by integrating factor, we just have to integrate both sides with respect to x. So here we integrate this side with respect to x, also this side with respect to x. Now here if you do the integration with respect to x, integration and derivative cancels each other, but therefore there's nothing is going to change. This is the only value that's going to remain. So we just have to write sec x y. I know this one looks xz, but this is sec of x y. Okay, and here we do the integration. Here if you integrate sec square x, you will get tan of x, and also we have to put a constant. Okay, but we will have constant both sides because we are doing the integration both sides, but we can combine all the constants together and write constant in just one side. In that way this is going to be correct. Okay, now the next thing is we have to express our final answer. Now 1 over x, sec of x y, we can write this one as 1 over cos x. Another way to write this one. So if I write 1 over cos x y, and here tan x we can write it as sin x over cos x plus constant, because finally we want to express our answer in terms of y. So if we have like this, what we can do is we can multiply every side by cos x. So if you do that, we can see it clearly. If we multiply this side and this side by cos x, what's going to happen? This cos x cancel. We will get y is equal to, in this side we will have sin x because this cos x cancels, and also we will have plus constant, and constant also multiplied by cos x, so we will have cos x. So this is going to be the final solution for this first order differential equation. But in case if the question have something like, for example, let's say if it's an initial value problem, they are going to give something like this: y of y is equal to 2. If they give something like that and ask you to find the particular solution, because if they don't give something like that, we will have a general solution for the differential equation. But if we have some value like this, we have to find the particular solution of the differential equation. Here y of y is equal to 2. Here what is the y value? This value is the y value. When x is 5, y is 2. So that's what this means. So this is y and this is x value. So all we have to do is just plug it in this equation and solve for c. And after we find out the c, we have to plug it back in the equation and express our final answer. Now let's go ahead and do and see what we get. Here if you plug y is equal to 2, so we just put 2 for y right here, and sine phi plus c cos phi, and we know sine phi is equal to 0, so we can get rid of this one. This is 0, and cos phi is -1. We put a -1 for this one, so negative c is equal to 2, therefore c is equal to -2. But we are not done yet. After we find out the c, we have to express our final answer. So we know that this is our general solution. For particular solution, what we do, instead of this c, we replace that one with -2 and express our final answer. So particular solution for this differential equation is going to be y is equal to sin x minus 2 cos x, and that's our final solution. What is that's our particular solution for this differential equation. I hope this helps. Thanks for watching, and don't forget to subscribe. See you next time.